Hello, this is Mr. Brooks and welcome to Lesson 5.2, Bisectors and Triangles. In this lesson, we're going to use properties of perpendicular bisectors and angle bisectors, and we're going to locate places equidistant from a given point on a map, from given points on a map. First, let's review perpendicular bisector. A perpendicular bisector is a segment line array that cuts a segment into two equal halves and intersects it at a right angle. You can only bisect segments. You cannot bisect a line or a ray. But segments, rays, and lines can all be bisectors, but they cannot be bisected. Only segments can be bisected. All right, our first theorem in this lesson is the perpendicular bisector theorem, which states that if a point is on the perpendicular bisector of a segment, then it is equidistant from the endpoints of the segment. And then its converse would be, if a point is equidistant from the endpoints of a segment, then it's on the perpendicular bisector of the segment. Now here we have segment DC, which is the perpendicular bisector of segment AB. You can see it's perpendicular to it, and it cuts it into two equal halves because you got two tick marks on AE and two tick marks on BE. So what the perpendicular bisector theorem is saying is that any point on DC has got to be the same distance from A as it is from B. So if we have point F, we know the distance from A to F is going to have to be the same as the distance from B to F, because any point on the perpendicular bisector of a segment is equidistant from the endpoints of the segment. The same is true with point G. Since G is on segment DE, the distance from A to G is going to be the same as the distance from B to G. All right. Any point on segment DC is going to be the same distance from A as it is from B. Now the converse of the perpendicular bisector theorem says, if a point is equidistant from the endpoints of a segment, like C is equidistant from A and B, that C has to be on the perpendicular bisector of segment AB. So C has to be on DE, which is the perpendicular bisector of segment AB. In example 1, we've got a map of Washington, D.C. Washington, D.C. was a very well planned out city before it was built. Most cities, you just sort of pop up and they grow at random, but Washington, D.C. was planned out before things were built. And see if you can find some things on the map that are equidistant from the White House and the Jefferson Memorial. Please pause the video while you try to figure out what is the same distance from the White House and the Jefferson Memorial. Hopefully you came up with pretty much anything on the blue line, M. Both reflecting pools are the same distance from the White House and the Jefferson Memorial. The Capitol is the same distance, and the Lincoln Memorial. Anything on the blue line would be the same distance from the endpoints of the red segment, which would be the White House and the Jefferson Memorial. Now let's try quick check number 1. See if you can figure out, it says CD is the perpendicular bisector of segment AB. See if you can figure out the length of CA and the length of DB. Please pause the video while you try to figure this out. Hopefully you decided that AC is going to be 5 because C has to be the same distance from A as it is from B. And DB then would be 6 units because D is the same distance from A as it is from B. Next, we have to make sure we understand how to measure the distance from a point to a line, or from a point to a segment, or from a point to a ray. If you're trying to get the distance from C to segment AB, or line AB, or ray AB, you always must measure perpendicular to the line. All right, it has to be perpendicular. You would not measure from here to here to see how far C is from line AB, or from here to here. You got to go perpendicular to measure that distance. Our next two theorems in lesson 5.2 are, excuse me, if a point is the angle bisector theorem. If a point is on the bisector of an angle, then the point is equidistant from the sides of the angle. All right, let's take a look at that one before we read its converse. Okay, if we have ray BD, or segment BD, bisects angle ABC, you can tell because of the arcs that it's an angle bisector, then D, which is on the bisector of the red angle, has to be the same distance to both sides of the angle. In other words, the distance from D to segment AB has to be the same as the distance from D to segment BC. All right, and again, you always measure perpendicular. Those two distances must be the same. Any point on the blue line, which is the perpendicular bisector of an angle, has to be equidistant to the sides of the angle. Now the converse to the angle bisector theorem says if a point is equidistant to the sides of an angle, then it's got to be on the bisector of an angle. So if we have point E here, and it's the same distance from E to this side of the angle as it is from E to that side of the angle, remember you have to go perpendicular when you're measuring that distance. If EF is the same distance as EG, then E has to be on the bisector of angle H. If ray, excuse me, if ray HE is the ray HE would have to be the bisector of angle FHG. Any point on the equidistant from the sides of the angle has to be on the bisector of the angle. Now let's look at example 2, using the angle bisector theorem. We know that F is on the bisector of angle BCD because of the arcs. So that's CF is the angle bisector. So F has to be the same distance from ray CA as it is from ray CE. So if we're trying to find the length of FD, first we've got to figure out x. Well, then we will set 5x equal to 2x plus 24, and we will solve that for x. You're going to subtract 2x from both sides, giving you 3x equals 24. Divide both sides by 3, so x equals 8. Once we get x to equal 8, we can plug it back in to 2x plus 24, which would be 16 plus 24, and so FD has to be 40. Now last, let's try to do quick check number 2. First question is, how far is K from EH and ED? Well, we can see it's given to be 10 from EH, therefore it has to be 10 from ED. So your answer to part A would be 10. What can you conclude about EK? Hopefully, since it's equidistant from both sides of the angle, it is the angle bisector of angle DEH. And how are you going to get the measure of angle X? You're going to take 2x and set it equal to x plus 20. Because if it's the angle bisector, those two have to be equal. So subtract an x from both sides, and you get x equals 20. And so what's the measure of angle DEH? So both sides of the angle have to be 40. So the measure of angle DEH would then have to be 40 or 80. This concludes lesson 5.2.